According to the National Electrical Code 2002, specifically Article 680.22a, the circulation pump for a pool is required to be on a separate branch circuit. Additionally, Article 680.22a mandates that at least one general-purpose 125-volt receptacle be provided for each 20 feet or less of pool perimeter. This receptacle must be located not more than 12 feet above or below the maximum water level and within 3 feet of the inside wall of the pool. Therefore, it is correct to request that the pump motor be on a separate circuit from the general-purpose outlet. This separation is essential for several reasons. Firstly, 680.22a explicitly requires the circulation pump to operate on a dedicated circuit. Secondly, general-purpose receptacles have specific requirements for location and spacing, as outlined in 680.22a3. These receptacles must be within 3 feet of the pool wall and within 12 feet of the water level. Separating these circuits ensures that the pump motor does not overload the general-purpose outlet circuit. Such an overload could create a significant safety hazard, potentially leading to electrical shock or fire. In addition to safety, separating the circuits allows for easier troubleshooting and maintenance of the pump system. If the pump is on a dedicated circuit, any issues with the pump are less likely to affect other electrical devices connected to the general-purpose circuit. This makes it easier to identify and resolve problems with the pump without disrupting other electrical services. The requirements of the NEC are designed to minimize electrical hazards associated with swimming pools. Pools and their surrounding areas present a unique electrical environment due to the presence of water, which is an excellent conductor of electricity. Ground fault circuit interrupters, often referred to as GFCIs, are critical safety devices in pool installations. GFCIs are designed to detect even small imbalances in electrical current and quickly shut off the power to prevent electrical shock. The NEC mandates the use of GFCIs in various locations around pools, including for receptacles, lighting, and electrical equipment. Proper bonding and grounding are also essential for electrical safety around pools. Bonding involves connecting all metal parts of the pool and its equipment to create a common electrical potential. This helps to prevent voltage differences that could create a shock hazard. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or GFCI and de-energizing the circuit. The specific requirements for bonding and grounding are detailed in the NEC and must be carefully followed to ensure a safe electrical environment. Pool lighting is another area of concern from an electrical safety perspective. Underwater lighting must be specifically designed and approved for such use. These lights typically operate at low voltages, such as 12 volts, to reduce the risk of electrical shock. All pool lighting circuits must be protected by GFCIs. Above-ground pool installations also have specific electrical requirements. These requirements are similar to those for in-ground pools but may have additional considerations due to the nature of the installation. For example, the metal structure of an above-ground pool must be properly bonded. Electrical inspections are a crucial part of ensuring pool electrical safety. A qualified electrical inspector can verify that the installation meets all applicable NEC requirements and that the electrical system is safe to operate. Regular inspections and maintenance are essential to maintain the safety of the pool's electrical system. Over time, electrical components can degrade or become damaged, increasing the risk of electrical hazards. By following the NEC requirements and performing regular inspections and maintenance, you can significantly reduce the risk of electrical accidents around pools. The goal is to create a safe and enjoyable environment for everyone. Understanding the NEC requirements for swimming pool electrical installations is crucial for electricians, pool contractors, and homeowners alike. This understanding ensures that the electrical system is installed and maintained in a safe and compliant manner. The NEC is updated regularly to reflect changes in technology and safety practices. It is important to stay current with the latest edition of the NEC to ensure that your pool electrical system meets the most up-to-date safety standards. In addition to the specific requirements for circulation pumps and receptacles, the NEC also addresses other electrical equipment used around pools, such as heaters, filters, and chlorinators. All of this equipment must be installed and wired in accordance with the NEC requirements to ensure safety. The use of flexible cords and cables around pools is generally restricted. Flexible cords and cables can be easily damaged, creating a shock hazard. When flexible cords and cables are permitted, they must be of the appropriate type and used in accordance with the NEC requirements. The location of electrical equipment around pools is also important. Electrical equipment must be located far enough away from the pool to prevent contact with water. The NEC specifies minimum distances for locating electrical equipment from the pool's edge. These distances are designed to minimize the risk of electrical shock. Signage is also required around pools to warn people of potential electrical hazards. These signs should be clearly visible and easily understood. They should include warnings about the dangers of electrical shock and the importance of following safety precautions. The NEC is a comprehensive document that covers all aspects of electrical installations, including those for swimming pools. It is essential to consult the NEC and follow its requirements when installing or maintaining a pool electrical system. Failure to comply with the NEC can result in serious electrical hazards, including electrical shock, fire, and even death. By following the NEC requirements and taking appropriate safety precautions, you can help to create a safe and enjoyable swimming pool environment. This commitment to safety is essential for protecting yourself, your family, and your community. Remember to always consult with a qualified electrician for any electrical work around pools. A qualified electrician has the knowledge and experience to ensure that the electrical system is installed and maintained safely and in accordance with the NEC requirements. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any specific electrical questions or concerns. The NEC 2002 provides specific guidance related to the placement and protection of electrical components near a pool. For example, underwater lighting necessitates the use of specific low-voltage transformers that are designed to isolate the lighting circuit from the main power supply, thereby minimizing the shock hazard in the water. These transformers must be listed and labeled for swimming pool use and installed according to the manufacturer's instructions and the NEC. Regarding the specific placement of the general-purpose receptacle, its location within 3 feet of the inside wall of the pool is intended to provide convenient access for pool users while minimizing the need to run extension cords near the water. Extension cords are often a source of electrical hazards around pools, as they can become damaged or wet, creating a shock risk. A 12-foot vertical limit above or below the maximum water level is designed to prevent the receptacle from being easily accessible to someone in the pool. In addition to the requirements for the circulation pump and the general-purpose receptacle, the NEC also addresses the bonding of metallic parts associated with the pool. This includes the pool reinforcing steel, the metal components of the pool structure, and any metal piping associated with the pool. The purpose of bonding is to create an equipotential plane, which minimizes voltage differences in the pool area and reduces the risk of electric shock. The bonding conductor must be of the appropriate size and installed according to the NEC requirements. The NEC also requires the use of ground fault circuit interrupters, GFCIs, for many circuits associated with swimming pools. GFCIs are designed to detect small leakage currents to ground and quickly de-energize the circuit, preventing electric shock. GFCIs are typically required for receptacles, lighting, and other electrical equipment located near the pool. The NEC provides specific guidelines for the selection and installation of GFCIs. Furthermore, the NEC addresses the requirements for electrical equipment rooms or enclosures associated with swimming pools. These rooms or enclosures must be properly ventilated to prevent the accumulation of moisture and corrosive gases. They must also be adequately sized to provide sufficient working space for electricians and other service personnel. The NEC also provides requirements for the wiring method used around swimming pools. Wiring must be installed in a manner that protects it from physical damage and corrosion. Underground wiring must be buried at the appropriate depth and protected by conduit. The NEC also provides requirements for the use of flexible cords and cables around swimming pools. In general, flexible cords and cables should be avoided if possible. However, if they are necessary, they must be of the appropriate type and used in accordance with the NEC requirements. The NEC also addresses the requirements for the grounding electrode system for swimming pools. The grounding electrode system must be properly installed and connected to the pool's bonding system. The grounding electrode system provides a path for fault current to flow back to the source, tripping a circuit breaker or GFCI and energizing the circuit. In addition to the specific requirements for swimming pools, the NEC also contains general requirements for electrical safety that apply to all electrical installations. These general requirements are also important to consider when working with swimming pool electrical systems. It is essential to consult the NEC and follow its requirements when installing or maintaining a pool electrical system. Failure to comply with the NEC can result in serious electrical hazards, including electrical shock, fire, and even death. By following the NEC requirements and taking appropriate safety precautions, you can help to create a safe and enjoyable swimming pool environment. This commitment to safety is essential for protecting yourself, your family, and your community. Remember to always consult with a qualified electrician for any electrical work around pools. A qualified electrician has the knowledge and experience to ensure that the electrical system is installed and maintained safely and in accordance with the NEC requirements. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any specific electrical questions or concerns. The NEC 2002 Article 680 provides a comprehensive set of rules intended to minimize the risk of electrical shock in and around swimming pools, spas, and hot tubs. Understanding and adhering to these regulations is paramount for ensuring the safety of individuals using these facilities. The requirement for a separate branch circuit for the pool circulation pump, as stated in 680.22a, aims to prevent overloading of circuits, which could lead to overheating and potential fire hazards. Pool pumps often operate for extended periods, and their continuous electrical demand can strain a shared circuit. A dedicated circuit ensures that the pump receives the necessary power without impacting other devices or appliances. The specifications for general-purpose receptacles near the pool, outlined in 680.22 AFRI, are designed to provide convenient access to power for pool-related activities while maintaining a safe distance from the water. The placement of the receptacle within 3 feet of the pool's inside wall minimizes the need for long extension cords, which can create tripping hazards and increase the risk of electrical shock if they come into contact with water. The height restriction of 12 feet above or below the maximum water level prevents the receptacle from being easily accessible to someone in the pool, further reducing the risk of electrical shock. In addition to these specific requirements, the NEC 2002 includes regulations regarding the bonding of metallic parts of the pool structure and equipment. Bonding involves connecting all metal components to a common ground, which helps to equalize electrical potential and minimize the risk of electrical shock. This includes the pool's reinforcing steel, metal piping, and any metal equipment associated with the pool. The NEC 2002 also mandates the use of ground fault circuit interrupters, or GFCIs, for circuits supplying power to receptacles, lighting, and other electrical equipment in the vicinity of the pool. GFCIs are designed to detect even small amounts of leakage current and quickly interrupt the circuit, preventing electrical shock. The proper installation and maintenance of GFCIs are essential for ensuring electrical safety around pools. Furthermore, the NEC 2002 addresses the requirements for underwater lighting. Underwater lights must be specifically designed and listed for swimming pool use, and they must operate at a low voltage to minimize the risk of electrical shock. The NEC 2002 also includes regulations regarding the wiring methods used around pools. Wiring must be installed in a way that protects it from physical damage and corrosion, and it must be properly grounded to prevent electrical shock. Additionally, the NEC 2002 addresses the requirements for electrical equipment rooms or enclosures associated with swimming pools. These rooms or enclosures must be properly ventilated and maintained to prevent the accumulation of moisture and corrosive gases. The NEC 2002 also includes regulations regarding the use of flexible cords and cables around pools. In general, flexible cords and cables should be avoided if possible, but if they are necessary, they must be of the appropriate type and used in accordance with the NEC 2002 requirements. In summary, the NEC 2002 provides a comprehensive set of rules intended to minimize the risk of electrical shock in and around swimming pools, spas, and hot tubs. Understanding and adhering to these regulations is paramount for ensuring the safety of individuals using these facilities. The requirements for separate branch circuits, general-purpose receptacles, bonding, GFCIs, underwater lighting, wiring methods, and electrical equipment rooms all contribute to creating a safe electrical environment around pools. It is essential to consult the NEC 2002 and follow its requirements when installing or maintaining a pool electrical system. Failure to comply with the NEC 2002 can result in serious electrical hazards, including electrical shock, fire, and even death. By following the NEC 2002 requirements and taking appropriate safety precautions, you can help to create a safe and enjoyable swimming pool environment. This commitment to safety is essential for protecting yourself, your family, and your community. Always consult with a qualified electrician for any electrical work around pools. A qualified electrician has the knowledge and experience to ensure that the electrical system is installed and maintained safely and in accordance with the NEC 2002 requirements. Remember that electrical codes and standards are constantly evolving, so it's crucial to stay updated on the latest revisions and interpretations. Consulting with electrical inspectors and industry professionals can provide valuable insights into best practices and ensure compliance with all applicable regulations. By prioritizing safety and adhering to established electrical codes, you can create a swimming pool environment that is both enjoyable and protected from electrical hazards.